Does
Oh,
it look
yeah, the homework was easy and I did it.
you did it? So see, I'll tell you, Meher, when I give homework, right? My intention is not to bother my kids. Okay, my intention is to ensure that whatever you are learning in the class, you are able to relate. You are able to kind of confirm that yes, what I learned, I know it, right? So I know the teachers who prefer giving a lot of homework. I don't. My attempt is always to give you enough homework so that you're able to practice and relook at all that we have learned and see if there's something that is not understood well, so that we can focus again on learning that concept. Because if you learn the concept, if you become comfortable with that, whether you do 5 sums or 25 sums, it's the same. But if you don't learn the concept and still you do 200 sums, it's of no use, or very little use, I would say, right?
Mm-hmm.
Okay. So um, can you tell me, okay, so let's do one thing. Can you show me your no, I'm just thinking, how will you? Okay, so whatever homework you have done, did you show it to your mom?
Yeah,
Did you, did you explain her what you have done and how you have done what you have understood?
yeah.
You did. Okay, because no, that's my that's the approach that I follow, because since you are doing it online, right? So I don't get to interact with you in person. So the parents become my biggest support system to make sure that it gives me the assurance that yes, whatever is taught is understood. Yeah,
Okay.
yeah. All right. So can you see my screen, the white screen?
Yeah,
Okay. So what I will request you, Meher, is uh, the notebook where you have done the homework. Just take a photo of that and send it to me in Telegram. Okay, so that I can just see how you are doing it, and if there's a need to kind of refine that, I will let you know. Yeah,
okay.
yeah. Just send that to me. By taking a picture on
Right now?
not right now. Later on.
Okay.
Right now, we'll focus on uh, what we want to learn. Okay. So again, trying to recall what all did we learn so far. We learned about the lines, line segments. We learned about the parallel lines, the properties of that. We learned about the triangle, predominantly the different types of triangles. Then we learn about the area of a triangle. How do you find the area of a right angle triangle, right? We learned about the how to find the area and perimeter of quadrilaterals, the rectangle, the square. Did we find the area of rhombus? Do you know the formula for finding the area of a rhombus?
No.
No. Okay. So let's start with that. So today we'll learn two things. Okay. The area of a rhombus, the area of a trapezium. Okay. And then a third thing will be the circle. Let's focus on these three things today. Is that okay?
Mm-hmm.
Okay. What is a rhombus? Let's
It,
recall the property. Yeah.
okay.
Rhombus is nothing but a squeezed form of a square.
Mm-hmm.
Let me quickly check if this is getting recorded or not, because today my screen looks little weird. Recording is happening. Yeah, it's getting recorded. Okay. Yeah. So you can see my white screen, right? Again.
Yeah.
Okay. So what is a square? A square is a quadrilateral where all the sides are of equal length and all the angles are 90 degree. Yeah.
Mm-hmm.
Now, when you pick two corners of a square, like this corner and this corner, and you start squeezing it, so this angle, this expands. So this angle becomes bigger than this becomes bigger than 90 degree, and the top gets squeezed because if the square is like this, you are putting pressure. See the top angle, this angle here, this becomes smaller than 90 degrees. So this becomes smaller than 90 degree. So that this is what is called a rhombus. So all the sides are of same length, but the angles are not 90 degree, not 90 degree. These angles are bigger than 90 degree. These are smaller than 90 degree. This is just a recall of the property. Now let's look at rhombus as a rhombus. I have kind of explained that enough. I have bored you guys enough with how a rhombus is formed, right? I have been squeezing the square to make a rhombus for two classes now. So what with whatever stunt we have done so far, this is a rhombus. Okay, meaning all these four sides are of same length and the angles are not 90-degree. Clear?
Okay.
Now, what it has? All four sides are same. Now, these are the four corners. We call them vertices. Yeah.
Mm-hmm.
Let's join them. Okay. Do you know what is this line called? Let's join the opposite corners of the.
Symmetry.
I'm sorry.
Symmetry.
Mm-mm. What is this line called? What is the name of the line?
The line of intersection.
Actually, these are called diagonals.
Oh, okay.
Diagonals are the lines that joins the opposite corners of the are the opposite vertices of a uh,
Okay.
here in this case a rhombus. So let's say if you're talking about a pentagon also, this could be one diagonal, this could be another diagonal, this also could be a diagonal. So these are like joining the opposite vertices of a polygon. That is called diagonal. Okay, clear?
Mm-hmm.
Now, when you are looking at this rhombus, okay, so here there could be only two diagonals actually, right? Because you have four corners, you can join the opposite two corners. If you join this corner and this corner, you're just making this line again, nothing new, right? If you're joining this corner and this corner, you're just repeating the same line. No need. Joining this corner and this corner, repeating the same line. So the opposite corners are these two, okay, and these two. We have two pairs of opposite corners. Opposite corners, yeah.
Mm-hmm.
These lines are called diagonals. Okay.
Okay.
So let's say if this shape is A B C D, so A B C D is a rhombus. So AC is one diagonal, diagonal one, and BD. When you join these two corners, BD is the second diagonal. I'll call it diagonal two. Whatever you call it, it's up to you. Okay. So there are two diagonals. Now, area of a rhombus is equals to come on, I'll say this area is equals to half into diagonal 1 into diagonal 2. Okay, this is the formula. Now you'll tell me how. Okay,
It's because it has like two diagonals.
yeah, these are two diagonals, so its area is half into the length of one diagonal into length of two diagonals. This is the formula that you'll remember. Now, how is that formed? It is formed by this.
Wait,
Okay,
what's the area again?
area is equals to half of the multiplication of two length of two diagonals d1 and d2.
Okay.
Okay, now how is this formed? So let's at least conceptually understand this. Ultimately you'll remember the formula, but it's important to understand the concept behind. Okay, so I'm not drawing it well. Let me draw it little better. So this is my rhombus. Okay, the property that you need to remember is this is my one diagonal, this is my other diagonal. Here In case of rhombus, the property is all these angles, basically these two diagonals meet at each other at 90 degree. So this is 90, this is 90, this is 90, this is 90. So if you look at this, it is actually breaking this into four similar triangles. This diagonal break the, when you know kind of make draw these diagonals, this breaks this whole area into four right angles actually, and all the right angles are same because I would not say same. It's not the same. Sorry, my bad. Mm, yeah, yeah. All these are not same. So this triangle and this triangle are same. This triangle and this triangle are same. So they make it uniform. Two pairs of right angles. This right angle, this right angle, this right angle, this right angle. Okay. There are four right angles. So let me make it little less messy. So the property that you would need to remember is that when I have a rhombus and I join the diagonals, they cut each other at 90 degree. Okay. This angle is 90 degree. This is 90 degree. This is 90. Okay. Now the area of this rhombus will be area of this triangle and this triangle, this triangle and this triangle. Okay. We have to join them all together. Okay. Yeah.
Yeah.
Now let's find out the area of this and this and this. That is what is going to give me the area of this rhombus. Okay.
Mm-hmm.
And if you look at this, let's look at this triangle. Okay. I'm just thinking, how do I break this easy for you? Okay. Let's. I will this time. I will keep it much cleaner. Okay. So we just need to remember two properties. Okay. This diagonal and this diagonal, they join at 90 degree and they split each other into two equal parts. So this length and this length will be same. This length and this length will be same. Okay.
Okay.
That is a property. So that means you will find out the area of this triangle, multiply that by 2. 2 times area of, let's say, A, B, C, D. And this is, let's say, O. So 2 times the area of AOB, this triangle. Okay. Meaning this triangle. So this triangle are same. Okay. In area. This triangle and this triangle will be the same. So the and 2 times the area of BOD, let's say, this triangle. Okay.
What's
So
the full form of B?
I'm sorry.
What's the full form of like B in the formula?
No, so I'm calling these vertices as a name. Okay. So B is just a point.
Oh,
A, B, C, D are the four vertices, the 4 points. Okay.
okay.
So I'm naming this triangle as the giving using the 3 points. So AOB, right? This is the triangle. If
Okay.
I'm talking about this triangle, I'm going to call it as AOC. So this makes it this triangle. If I'm talking about this triangle, I'll say BOD, and this triangle is this. Okay. So now let's. So the property that we need to remember is these two diagonals meet at 90 degree and they cut themselves into two equal halves. Okay. So if I call this as A, and this is B, this is C, and this is D. Okay. So here A will be equal to B and C will be equal to D. C and D, this is a length. Okay. So what I'm saying is when you're looking at a rhombus, when you're joining the opposite corners, that make this is called diagonal, and the diagonals meet each other at 90 degree and they break themselves into two parts. Okay. Yeah.
Okay.
So this and this C and D are same, A and B are same. Now A plus B is your one diagonal from here to here. Okay. C plus D is your second diagonal. Okay. Diagonal 2. This is diagonal 1 and this is diagonal 2. Okay. Are you with?
Mm-hmm.
uh, okay. Now, so what I was saying was, when this happens, you are making this as one triangle and this as another triangle. These two are same in area because, see, this side and this side are same. This side and this side are common. This side and this side are again same length. That means this area and this area are same. Okay. So we'll have to just find out the area for one triangle. This one triangle, and multiply that by 2. That will give me this part of the area from here to here. Similarly, for this, uh, uh, here we'll find out the area of this guy and multiply by 2, because this side and this side are same. This is common, and this are same in length again, right? So these two are exactly the same triangle. Okay.
Okay.
So we'll find out the area for this, multiply by 2, find out the area of this, multiply by 2. So I have made it look very dirty. So I'm just cleaning it up. Okay. Now, area of this guy. This is a right angle triangle. We know area is half times the two length of two sides, which makes a 90-degree. So this A and D. A into D. Okay.
Okay.
This is the area of this guy. I will multiply that by 2. Okay.
Mm-hmm.
Now, what is the area of this guy? This is another right angle. This is half of the area. We have found this area. Now look at this area. This is 2 times the area of this guy, 2 times area of this triangle. This triangle is B and D. Okay, so 2 times half into B into D. Okay, so here, this the first one, this part becomes, see, 2 into half is 1 actually. So A into D, and this is 2 into half. This becomes B into D. Okay,
Okay.
so let's clear this up. A into D, or and B into D. Okay, so now let's make it clear. We said this is A, this is B, this is C, and this is D. Okay, and this part of the area came as A into D, and this part of the area came as B into D. Okay, if you sum them together, that becomes A into B plus B into D. Now I will acknowledge something. I told you a wrong formula. We'll just fix it. Okay. Now here A into B, B into D. Sorry, is this A into D? Sorry, it was A into D. And sorry, it was A into D. My bad. Let me do it again. So this is this one. This is my diagonal, breaking into two parts: A, B, C, and D. Area of this guy is half into A into C, and this and this are same, so I will multiply this by 2, so this becomes A into C. Okay, now I'm looking at this guy, which is half into C into B, and then this has to be doubled so that I can take this also, so this becomes B into C. So remember this, A into C and B into C. Okay, so now
Okay.
so now in this rhombus, this is A, this is B, this is C, this is D. A into C, uh, B into C. Okay. So now here, this becomes C is common, A plus B. So basically, I'm adding this area. I'm adding this area and this area. That will give me the total area of the rhombus. Okay. So
Mm-hmm.
this equals C into A plus B. Now, if you look at A plus B, okay, A
Okay.
plus B is the full diagonal, this diagonal from here to here. Okay, I'll call this as D1, and C is half of this diagonal from here to here, right? Because this divides into two parts. Yeah. So the formula was right. Okay. So, okay, you would have looked at a lot of complicated things. Okay. It is not complicated. When you look at this is what I'm doing. Now, you already know the area of a right angle triangle, right? If I have a right angle triangle like this, and this is the other two sides making 90-degree, my area is half into A into B. Okay. I'm just using that formula. What happens in case of rhombus is you join the diagonals. Okay, they cut at 90-degree, meaning they make right angle triangles. Okay, so this makes right angle triangle. So and they intersect, they split them to two halves. So this diagonal is breaking this diagonal into two halves, so here and here are same. Similarly, this diagonal breaks this guy into two halves. Okay, so this and this part are the same. So basically, I just added the area of the four right angle triangles. Okay. So this right angle triangle and this right angle triangle are same because this side and this side are same, divided into half. This side is common between the two triangles, right? Same length. And this is also same because it's a rhombus. All sides are of same length. So this triangle and this triangle are same or in same area. So you just find the area of one triangle, multiply that by 2. That becomes the area from here to here. Similarly, at the bottom, if you see, this is common angle, a common side between this triangle and this triangle. This is half of this. So I'm sorry, this side and this side are same. And this one and this one are same in length. So this triangle here and this triangle are also the same. So if I find the area of this triangle, multiply that by 2, I get this full area like we got here. So you just add these two areas and you got that. So basically, after doing all that, what I got was total area was equal to C into one diagonal. And this C was this part. So half of the diagonal. So that is how the area of a rhombus is half of diagonal 1 and diagonal 2. Okay.
Okay.
It might have looked little cryptic, Meher. That is okay. I just told you the concept. You just forget about what I did. You just remember that the properties, okay? Because geometry or maths or any topic that we learn, it's all about the concepts. The concepts that you have to remember is the property. So when I'm talking about a rhombus, what happens? My diagonals split each other. When they intersect each other here, they split themselves into two parts, equal parts. Okay, and
Mhm.
they intersect at 90-degree. If you remember that formula, that concept, that okay, diagonals of the rhombus intersect each other at 90-degree, and they split themselves into two equal parts. Basically, the diagonals split themselves into two equal parts. That is more than enough, because then you'll be able to relate that yes, this is a rhombus. This side, this side, this side, this side are same. And when the diagonals are meeting, this side and this side are same. Meaning this part and this part are same because this guy is splitting into two parts. Similarly, this part and this part are same because this diagonal is splitting this guy into two parts. So then you can see the picture here. Okay, that yeah, this is one right angle triangle, this is another right angle triangle, both are same. This right angle triangle and this right angle triangle, they have all the sides same. That means the area is same. Okay. Then you apply the formula for area of a right angle triangle, half into base into adjacent side. You get the area. This area multiply by twice gives you this complete area from here to here. Similarly, you get the area of this guy, multiply that by 2, gets you the area for this whole side. Okay, you add the area. So basically, when you're talking about area, if I'm talking about this area is nothing but this area plus this area, right? If somebody is talking about, let's say, come on, area of this triangle, this I can break it into as many parts. So this area plus this area plus this area plus this area is the total area. Yeah,
Okay.
yeah. So likewise, for rhombus, the formula of area is equal to half of diagonal 1 into diagonal 2. Diagonal 1 is this diagonal 2 is this diagonal. Or you can think other ways. Just if you have the length of both the diagonals, you can multiply them with each other, divide that by 2. That becomes the area of your rhombus. Clear?
Mm-hmm.
How is this area formula derived? That also I showed you. It's up to you. If you find this interesting, you can try it by yourself. Revise it. If you find memorizing the formula is easy, you can choose. But I prescribe always that no, we should dig into it to memorize the formula. I mean to understand how the formula is derived, because it's not just about somebody giving you a formula and you applying the formula. If you're able to relate how it works, it lasts longer. Yeah.
Mm-hmm.
Okay, somebody is joining the class. Who is somebody? Hmm, right now, what is the time? 22. It's let me see who is trying to join. Okay. Hello, Gautam.
अच्छा.
Hello, Gautam.
Hi Ayush, come बेटा.
Uh, अच्छा, uh,
Yeah, Ayush is coming. Thank
so
you, sir.
no, Ayush ka class will start after 20 minutes. So if
Okay,
he's
after 20 minutes. Okay. Okay, I will log in again. Thank you.
yes, sure, sure, no problem. Okay, all right. Chaliye. Sorry for the disturbance. So the kids from the next class are also joining little early today. So you're with me so far?
Yeah.
Yeah. So far what we have done is we kind of broke our head with how the area of a rhombus is derived. Okay. Just by knowing the property of the diagonals. Okay. I will not repeat myself, but the area formula that we should remember is half into diagonal 1 into diagonal 2. Okay. So now let's do one sum. If somebody says that area of a rhombus is, let's say, 160 centimeter square. Okay. One of the diagonal is, let's say, 12 centimeter. What will be the length of the second diagonal? How will you do that? What you will do, the area equals
The
half.
diagonal one.
Sorry, go ahead.
Multiply by diagonal 1 into diagonal 2.
Right. So I know diagonal 1, I don't know what is diagonal 2. What I know is the area. Yeah.
Yeah.
I know the area is 160 centimeters square. Here, in case of all the calculation, always be watchful of the unit. Okay. Sometimes the examiner will play with the unit, and then that changes the whole thing. Okay. So that let's be a little careful there. Okay. Now here centimeter squares and centimeters, so it looks fine. So 160 equals half into 12 into d2, the second diagonal that we are trying to find out. Now here you can always, I don't know how you guys do it. You can always do it 12 as 2 into 6, right? Right, that is this. Yeah. So then you can, so this is, come on. So this is, so you can do tic tac toe of these two. So 6 times d is 160 centimeter square. So six times of d2 second diagonal equals 160 centimeter square. Okay, so 6 times d2 into centimeter. So this was 12 centimeter. So now d2 you'll divide both the sides by 6. So it becomes by 6 by 6. So this becomes d2 equals uh, 160 by 6. That'll be the answer, right? So basically, if you know the formula, you have to look at the question, see what are the things that you know, what is the formula that you know, and what is missing. Put everything in the formula that you know. I mean, if all the values that you know in the formula, and see what is remaining to be found, and then you can think backward. Yeah.
Okay.
Now, there could be other questions. Okay, one diagonal one is 20 centimeter, and diagonal two is 40 centimeter. Find out the area. Straightforward. You'll just apply half into first one into second one. Okay, and you calculate it. Correct.
Mm-hmm.
Now, one more thing I want to kind of reiterate before I move forward. Whenever you're doing any sum, okay, always think of that as a story. It's like you're telling a story, because the person, right, whatever you're thinking and doing, I would not know as an examiner. So when you tell that story very clearly to me, it becomes very easy. Okay, let's say I'm doing that formula, the first sum that we were doing, right? That the question says area is 160 and no centimeter square, and one diagonal is uh, 10 centimeter. And what is the second diagonal? So I'll say, okay, we know area equals to half into diagonal 1 into diagonal 2. Here, area is given as 160 centimeters square. So equals half into 1 is given as 10. And then second one, I don't know. Okay. So that means this becomes 160 centimeters square equals to half divided by 10 is 5 centimeter into second diameter, second diagonal. That means 160 by 5 centimeter. So centimeter and centimeter square. So I'll divide this by centimeter here, and here also by 5 centimeter into D2. So this centimeter and this centimeter, only 1 centimeter will be left, and 160 by 5 becomes 5 3 is 32. So 32 centimeter equals. So here, when you're doing step by step, right? What happens is, when I read this, I'll be able to make out that how you are doing the calculation, and you will also be able to do the review. Okay. So don't jump steps. Okay, when you're doing the calculation, when you are solving the sum, always do step by step. That is why I asked you to send your homework actually to me. So when I look at that, I'll be able to understand whether you are going in a step by step manner or you are jumping steps.
Okay.
Because see, everybody has different level of intellect. Okay, you might be a very smart kid, I might be a average kid and during my childhood days. So I will probably not understand the way that everybody understands. So that is why when you put it step by step, it helps the examiner to understand what you are doing, and it also helps you with the review. Tomorrow, no, after finishing that sum, if you have time, you want to do a review. When you go back, you'll be able to read it like a story. It will be easy to comprehend and kind of do whatever it requires to be done. Okay.
Mm-hmm.
So this is the rhombus. Now there is one more shape that's we can talk about. This is called trapezium or trapezoid, whatever you call it. The property of this guy is this is also a quadrilateral, meaning it has four sides. Only one pair of sides are parallel to each other. There is no other property. Okay. Let's say if this length is A and this length is B. So there are two parallel sides only. And when the sides are parallel, that means there's a fixed distance between the two lines, right? So let's say the length is H. Okay. So the area of a trapezium or trapezoid is half of the height between or the distance between the two parallel lines multiplied by the sum of the length. Okay. You will ask me how. I cannot explain you how, because for Doing this, you would need to understand a bit of calculus. And I believe you guys have not started calculus yet, correct?
Yeah.
So I will not overwhelm you by teaching you calculus concepts and then you get lost. Okay.
Mm-hmm.
So, for now, we'll just remember the formula as the area for trapezium or trapezoid is half of the height or the distance between these two guys, the two parallel lines only, half of the height multiplied by length of both the parallel lines. Okay, A plus B. So if this length is A and this length is B, so you will add the length, multiply that length with the height between the two parallel lines and divide that by 2. That will be your area. It's a formula that you might want to remember. So the sums that can come is, I will give you some sums, okay? That, okay, find out the area of a trapezoid where the two length of the two parallel lines are given and the height is given. Height or distance between the two lines is given. Or I can say, okay, find out the height if the two sides are given and the area is given. Okay. So these are two types of problems that you will deal with in case of trapezoid as well as rhombus. Okay. I'll give you some sums.
Okay.
You try doing it. It's okay to get stuck. If you get stuck, let me know because I want to know where my kids are getting stuck and why. Okay. So,
Mm-hmm.
let's focus on these two shapes for today. Let's not go to circle because no, if we learn too many things, we'll forget too many things also. Okay. So what we have learned is rhombus and we learned about the trapezoid. Okay. Area of a rhombus is 2 times, sorry, half of multiplication of both the dimensions d1 as both the diagonals d1 and d2. Okay. Multiply both the diagonals, divide that by 2. That gives the area of your rhombus. Okay. How this area is derived, that also we figured out because the property of the rhombus is when the diagonals intersect, they intersect each other at 90 degree and they divide each other into two equal halves. Okay, so we just broke that into smaller shapes, right angle triangles, and added them together. That's what gives this formula. Okay, now when you talk about trapezoid, your teacher did not tell you how this area is derived, but the area is equals to half of the height between the two parallel lines, the distance between the two parallel lines multiplied by sum of the two sides, sum of the two parallel sides, sum of the length of the two parallel sides. This is the formula. Okay. Yeah.
Yeah.
Now we'll learn about circles, we'll learn about cones, we'll learn about prisms, we'll learn about cubes and cuboids. Let's just spend some time to understand how those shapes are built. If you know circle, okay, if you keep circle after circle after circle after circle, meaning like this. So this is one circle. You're keeping another circle on the top of that. Keep putting circles after circles after circles after circle. This makes your cylinder. This is called right cylinder. Okay, or a cylinder. Yeah. So this is like a cylinder. This is not a perfect cylinder. Here it's a smaller circle. Here it's a bigger circle. But ultimately it's circle after circle. Okay. So this is not a perfect cylinder. But if you only look at this portion where all the circles are of same size, this is a this portion can be called a cylinder. Yeah.
Okay.
Similarly, we learn about the rectangle. If you keep so many rectangles on the top of each other, does it look like a matchbox? Does it look like a matchbox now?
Yeah.
This is called cuboid. Okay. So basically, if you keep rectangle after rectangle, right? If you recall, the breads that we buy in Costco or Walmart, right?
Mm-hmm.
These are like you can imagine one bread is looking like a rectangle. You are putting so many breads after another. That makes a shape called cuboid. Okay, I'm just giving you a view of how these, three. So these are called three-dimensional shapes, meaning this is length and width, and then this third dimension called height that comes into picture. Okay, if you are looking at the circle, this is on one surface. So far, we were talking about area. Put so many circles after each other, that makes it a cylinder. The third dimension. Basically, when you include height, that is when the third dimension comes to the picture. You all would have eaten ice cubes from the fridge. Yeah.
Okay.
This is nothing but a small square adding height that makes it cube. Okay.
Mhm.
So uh, square makes cube, rectangle makes cuboid, circle makes cones. Sorry, circle makes cylinders, and they also make cones. Okay. Okay. This is just a concept I thought of, making you aware of, so that when we go to volume and three-dimensional shapes and the surface area and those things, we'll talk in more detail.